Yoma, you are muted. Unmute yourself.
Okay, sorry. Okay, so thank you, Matthias, for your nice introduction, and thank you, Sener, to joining together with us. Behalf of myself, welcome also to this first webinar. My name is, like Matthias say, Jorma Vitkala, and my great pleasure is to introduce our first speaker in this webinar, Professor Dr. Sener Oktik. He's a senior lecturer and researcher in Karis Has University in Turkey, and he's also the member of the board of directors in Sisecam headquarters. And Sener has also been the TCO in Sisecam before his retirement. Sener has been a keynote speaker in many different international conferences, as you have most probably heard him in those places. And today we have a great honor to get his overview about the global glass market and what is the situation at the moment. But shortly and nicely, welcome, Sener, and thank you very much to helping us to get this overview. And everybody else, please write your questions during his presentation, and Malte will be handling those one then also. Okay, Sener, the floor is yours.
Yoma, I do thank you, and I do thank everybody really putting all this effort to get this together. I thank with Matthias and his friends at Glass World. Okay, the glass market, you said, it's not easy really to put the finger on at any time, but I will try to really give some compiling information on the glass, which I have been really reading, listening, and doing some search. I hope those connected for this webinar will be happy enough after spending this an hour at least together with us and get something out of this talk. If you allow me, may I share my screen? Okay.
Yeah.
Okay, I'll put in the presentation mode so you would be able to see properly. And as you can see, I have got two titles. One is a senior lecturer, as Yoma already explained, and another one is a member of our board of directors at Sisecam. Although I moved back to university, I'm still working on some subject related to glass. Okay, this is my disclaimer. Everything I said really collected from the open sources and some of the interpretations in Sisecam and some work at Sisecam. I'll try to go through a short overview of a global flat glass. Then I'll touch upon a thin flat glass and challenges and opportunities for architectural applications. And energy efficiencies and architectural glass, another subject really I'll be trying to summarize some of the information I have. Then the coated flat glass global outlook, and architectural glass and glazing industry. And finally, it's quite important and it's coming quite fruitful for everyone, multifunctional smart coatings on glass. Okay, when we say glass, anything really thicker than 1 millimeter is called conventional flat glass. And when you go down to 1 millimeter to 200 micrometer, it's a curved glass. You can give a shape easily. But if you go lower than 200 micrometer, you are talking about flexible glass. Okay, I'm not going to read all of these, but you can have architectural glass, automotive glass, and special applications on home appliances, solar glass, technical glass, and printed electronics is quite important area. When you look at really what I have for 2021, the global production of glass is around 83 million tons as per year. When you look at really 63% of those is annealed and toughened laminated glass used in architectural applications. 27% of that is passive or active layers coated flat glass. And as safety security glass accounts for quite a small amount, as you can see. But you can see where it is going. For instance, most of you probably have seen it. That 23-meter long with 6 layer of century glass lamination of 20-millimeter glass by North Glass. It's quite interesting. What are the really aggression in architectural applications for the size of an application of glass? When you look at that, who is producing in the world that 83 million tons in 2021? As you can see, NSG this year is taking the lead with a 7.6%, then AGC, Saint-Gobain, Guardian, and Sisecam was 3.9%. Taiwan Glass, then comes Vitro, etc., etc. And it's seen that actual production really improved from 220 to 21 is around about 4%. But when you go back to Europe, who are in Europe really producing those? As you can see, this figure changes slightly in Europe. Sisecam has 22% of European flat glass production. Compared to others, we can say that Sisecam is leading the flat glass production in Europe. But when you look at that 63 million tons a year towards 2025, it is expected that there will be 7% CAGR. That's accumulated annual growth rate, 70%. It's going to be up to 112. When you look at the internet and the reports, these are fluctuating significantly, these figures, but this is kind of average. And I think, in my opinion, these figures are sensible to really give the picture of what's happening in the flat glass. But when you look at that, regional distribution is that, as you can see, North America is really a bit, not very, North America don't have really high appetite for glass production anymore. It's going to 5.5 million tons a year. Out of that, 443 floats, there's only a small amount of only 27 float lines in North America. As you can see, Europe is fluctuating. Russian and CIS, you can see recently in 2020, it is dropped from 3 to 1.7, and there are 18 lines in Russia. China has 225 lines, quite high. And this is the situation regionally. I'm not going to really read each part of the world, each continent. But as you can see, Middle East and Africa is growing. Europe is fluctuating. South America is now stable last 5 years. Asia Pacific going quite high. It went up to 53, 218, and now 2020 is 50.5. Okay. This is really lower than the demand. Actual demand is currently higher than what the world can produce in flat glass. As you remember, we mentioned 83, now is 102 million tons glass needed for flat glass demand. So actual production is lagging behind. When you look at the price of flat glass, the average in 2021, as you can see, it fluctuates around $300 per metric tons. But how much area depends on how thick really they are used in the architectural or other applications. But roughly, when you look at the construction, new buildings and facade is 40% of that 80% share the architectural applications have in flat glass. And in automotive, 13%, quite small percentage in total, but 80% goes to original equipment and replacement is 20%. Other applications like white goods, furniture, technical glass, display, electronic, solar glass, etc., is 7% of total market in 2021. Okay, if you go down to less than 1 millimeter area for thin glass, as you can see now, you can have a roll-to-roll glass. How can you apply those in architectural applications? But believe me, there are significant literature. People are trying to really apply this kind of glass in different usage of architectural application because of the curvature, because of the environmental issues, etc. Okay, when you go to thin glass, actually, what is a problem? Problem is the expensive raw materials. The batch is quite expensive. And these glasses are very sensitive for contamination. And they need innovative production technologies. And you have innovative in every point in the cutting, piling, transporting. You need a special attention in the thin glasses. This is creating significant problem for really penetration of thin glass in the architectural applications. When you look at the actual production, for instance, capacity currently up to 2 and 19 millimeter float, you can have up to now actually in Turkey, Sisecam is aiming to 1,200 tons float. But if you go to thin float, it drops down significantly. If you go 0.32 to 1.1 millimeter, actual pulling rate is quite small. Glass ribbon has to reduce. That means all cost. This is comparing normal float and a thin float. But as you know, you can really produce thin glasses using down-drawn fusion. But again, it is quite expensive. And it is, I don't think in the near future, will be really used in architectural applications. But there are other applications heavily using that glasses produced with this down-drawn fusion technologies. These are some of the companies really dealing with thin glasses, AGC, NSG, and most of them is Stiek and Kinji glass. As you can see, they are really taking some 100 to 150 ton a day float lines to really go into the field of architectural applications as well. These are the advantages and disadvantages and challenges needed for the thin glasses. Advantages: reduced use of raw materials. This is quite good for environmental issues. Low weight. That's what really architectures is asking, reducing the weight of actual facades using these thinner glasses. And the higher flexibility, there are certain architectural applications has a significant different shapes and curves, and actual thin glass can really deal with that easily. What challenges? Low bending stiffness of the element. Mechanical reliability is low still. Design of the support elements for thin glass is problematic. And the cost of course, and the production is not really clear for different companies, sheet to sheet or roll to roll. Energy efficiency is quite important because, as you can see, building is consuming quite a significant energy of the total global energy consumption. And as you can see, intensifying building in the cities, we're coming up with this kind of buildings. These are the 14 super tall buildings in the world, 14 of them. But you need efficient use of daylighting in these buildings. You need energy efficiency, energy production, safety, competitive cost. And there's a rough estimation of how much facades in the United States. It's estimated 5 to 7 billion square meter facades if you are able to do something with it. Those shapes really sometimes is quite suitable for very thin glass applications or combination of thin glass applications. Okay, residential and commercial building energy, when you look at that, there's mostly they use electricity. So if we can have some kind of help producing electricity from the facades, while we are really still having the comfort of having visuals. As you know, those energy efficiency, we were discussing with Jorma. Now, I think in Finland, you need to have a U value of 0.7. Most of the buildings, this kind of compulsory. For this, you need the coated glasses, solar glasses, and the triple glazing to really beat the actual concrete wall insulation. This is why we need, because that is net zero global carbon dioxide emissions. And as you can see, building has some kind of a contribution, this almost 36.5 gigaton carbon dioxide emission this year. So this has to be reduced. Coating. When you coat the glasses, you have to comply with demands by industry and designers. This is quite important. You have to really comply with environmental issues, and you have to comply with structural and aesthetic requests. And of course, you have to comply with the end users' economy and comfort. What are the deliverables by coating on glass? Thin film layers, controlling light and heat by tailoring transmission emission of electromagnetic spectrum for desired environmental condition. For this, you can have a dynamic or small switchable coatings to control light and heat, which is called smart glass applications. Non-switchable, quite common, it's quite commonly used, non-low-E tinted glass or reflective coatings, passive low-E coating, pyrolytic coatings with poor solar heat gain and visible transmission and reflection performance, and solar control low-E. These are multi-layer coating, as you know, with solar heat gain and visible transmission performance. This is the kind of really differences between using single, double, and triple layer of silver in the coatings. As you can see, when you got a triple glazing with a triple silver, you can see how you can play with U values down to 0.7, as Norma was suggesting for the Finland. These are the solar spectrum of single, double, and triple glazing. This is really what you have with different low-E coatings. You can really play with transmission. This is called clear glass, 85% transmission down to 25% transmission. I displayed one of the Sisecam coated glasses, Sisecam template for low-E samples. These are the figures. Whoever interested, I'll be sharing the presentation anyway. And this industry, where is it going to? How am I doing with the time? It's okay. As you can see, there are different companies from AGC, Saint-Gobain, Guardian, Sisecam, Guardian El Fuayo, trying to produce coated glass in different parts of the world. But as you can see, they are really well scattered, but Europe has the largest production sites. And you can see how many companies in Northern America, Latin America. These are the sort of producers distribution of the world for the glass, coated glass production. Again, when you say the coated glass section, you've got Saint-Gobain really having a 72% share. It's quite high. AGC 77, Guardian 7, etc. And we are in here, Sisecam is less than 1% yet, but it's changing. It'll be sort of, it'll be a little bit higher with the recent investment Sisecam is doing on coated glasses. This is how much in 2016 produced as a million tons, and how much money really there in $1 million in 2016 and 2021. You can see the growth is 6.5% in the production capacity, and the market grew almost 6%. In there, of course, as I explained, there are different technologies. With those different technologies, you put a different price tag on each coated glass. Magnetron sputtering is the major coating technology used in the world now. It was 60%, now it's over 62%. It's not growing that fast. And prolific coating is going a little bit down. Sol jets is quite small, and others, as we can see, negligible. So in this field, main technology is sputtering. When you look at the energy efficient windows, because this really, when you say energy efficient windows, the market really includes glass, framework, and other bits and pieces, all BOS. In 2021, it has assumed that it's almost 13 billion. And within 5 years, it's expected to grow 7% per year to up to 18.3 billion. It's a quite important market. And most of the market is double glazed windows, and 35% is non-residential. So those double glazed windows and replacement windows really having 65% of the market. Who's using? As you can see, this figure is a bit old. This is really going to 2015, but there is a projection to 2021 from 5 years back. But as you can see, Europe is leading at that time, but currently North America is leading in energy efficient windows. That switched from Europe to North America. Middle East and Africa is quite small. Asia Pacific is growing mostly in China. Okay, switchable coating and dynamic coating, smart coating is quite important area. You've got two different sections in here. The first one is passive self-regulating control windows. These are thermochromics, photochromics, and gasochromics. You know what they are, most of you in the audience. And the active dynamic control windows, electrochromic, thin film devices. These are devices we have to be really careful when you refer to it. Suspended particle thin film devices, liquid crystal, polymer dispersed thin film device, and liquid crystals. These are all on the market. Unfortunately, electrochromic is not taking as much as part really in this market. They cannot grow as much as they like. Probably some of you really experience in the airplanes. Now they are using electrochromic shutters instead of mechanic shutters in the airplanes. All those suspended particles are cheaper, and as they are mostly used for internal applications like meeting rooms, etc., etc. But that is growing fast. But it is expected that actual smart multifunctional glass and surface coating market will grow significantly, has been growing from 2018 and 2020, almost 19% per year. This is how it is really shared with different technologies, thermochromic, suspended particle, microplines, photochromic, etc. These are the market share of different technologies in a million units, and that's the financial part. As you can see, again, suspended particle is taking the lead. All right. When we look at the smart window market, now currently I think it's 206 million in 2021. Within 5-6 years, they are thinking of almost triple, or almost 2.5 times, 2.25 million in 2021, with the cumulative annual growth rate is with 15%. And the last but not the least important part is producing energy from the facades. For that, we need the transparent photovoltaic devices. You all know that actually with the conventional photovoltaic devices, mostly you use the visible region of the electromagnetic spectrum. But now with the new technologies, just allowing the visible region, and you can really produce electricity from the other part of the electromagnetic spectrum. For that, there are different technologies. One is a luminescent solar concentrator, which is taking significant part of this area. And as you can see in here, you are really diverting the light with the waveguides to the side of the windows and putting the photovoltaic devices on the side of the frame and trying to create electricity. But actually, true organic photovoltaic technologies have wavelength selective transparent organic PV system, and a luminescent solar concentrator system, and a novel design. Actually, this is developed in the United States in MIT, I think, or Stanford University, I'm sorry. And now it is almost at the pilot production line. There are Michigan State and MIT developed that, I'm sorry, and ubiquitous energy, now really working with NSG to produce those windows for truly transparent photovoltaic devices. Pfizer, another European manufacturer, and Bright Solar is another one. And if we can insulate, we can integrate the transparent photovoltaic in EGU units, and we have selective visible light, and we can really have simultaneous block transmission and unwanted solar heat. So have multi-purpose when we have transparent organic photovoltaic cell on our facades. We need to improve the power conversion efficiency, visible light transmission, and solar heat gain coefficient, and of course the emissivity. Color is another important bit. You can have product like that now in the market, and you can see it's quite acceptable in visibility and can produce up to 10% of the solar energy into electricity. As I said, these are the different companies have different approaches, and these are some of their recent figures on the efficiency and other properties. Just imagine really covering all those buildings with those organic, transparent photovoltaic devices. How much of energy you can produce and how much of carbon emission you can really avoid by doing so. I do thank you for listening to me. I hope I'll manage to give some taste on the field of flat glass, coating on glass, and functional coatings on glass. Thank you very much, and I'll try to reply your question. Okay, Matthews and Yoma, it's back to you. I cannot hear you, Yoma.
That's always you try to mute it that you don't get it any noise over there when you give it your presentation. But thank you very much. That was excellent presentation. Give it a good overview to the whole through the whole things. And Malte, you might have it some questions over there, but when you check it, those one, I would like to first to ask it this one question from you anyway, but I perhaps before that one, Matthias, you would like to say something also. You are muted. You are muted.
Matthias,
Okay, sorry. No, okay, good. So yeah, can you hear me?
Yes.
Just a
Yes.
quick. Thank you, Jorma. Just a quick one. So this, for me, the energy production of glass is fantastic if you have it on the facade. I mean, this is the perfect way. So do you think there will be a big push, because at the moment you don't have many buildings with that, and also there's the talk, oh, it's too expensive, we cannot afford it, you know. So what is your guess about this?
well, I can see Bernard is here. Bernard might have an idea, but the problem is, of course, this kind of applications need each unit needs to be produced properly by the actual producers. So most of the producers do not take really a task of dealing with the buildings, because each building has a different project parameters, different windows, and this is creating some kind of problem. For the actual standard units in the buildings, I think it's quite doable. And NSG, as far as I know, now having a pilot production line on this ubiquitous technology with the efficiencies around about 10%. So, which is quite good. Cost-wise, they are not very expensive. Transparent organic photovoltaic coatings are very cheap, because material is cheap, technology is cheap, and actual thing is R&D was quite expensive. Probably they are charging currently on the cost.
Okay, thank you.
Very good, Sener. But this is very important to you anyway, this PV things, because you have been the president of Turkish Solar Energy Association many years, and your background is really to develop, of course, the different coatings, what you have done it always, but also the PV panels. So that's a important part of the work what you do it in a globally. But as you mentioned it, that there is a huge potential in a PIPV. How do you really see about this non-transparent and transparent PV market when we can see it? Let's say those transparent PV coming, because that looks so promising anyway, that you can see through the windows and make it the electricity also at the same time.
Yes, Yoba, as you were mentioning, the non-transparent BIPV is already on the market and it's already in applications. You can see many buildings with a non-transparent PV. But for transparent PV, there are only a few applications, but it's coming up there because actual building design these days are mostly, windows with the transparent functions. All the facades are really transparent. So actual area needs transparent photovoltaic. If the area will be utilized for this purpose, I think the transparent photovoltaic will be with us in the near future. Non-transparent is already taken up, especially facades and the roofs, as you know. It's quite high.
Okay, so I like to, if you have questions, please lift the hand. There's a little icon and speak directly, or write it in the comments. I have another question for Sener so far. What do you think about this war in Ukraine? What kind of impact does it have on the glass market, since we have in Russia some production lines running, which are from international companies, which are not in use anymore, or maybe I don't know how this is going on. Will this have a really big impact in your eyes? or can we catch up with that within the European productions?
Well, as we all see from the news, they have destroyed significant amount of facades.
Okay.
Kilometers and kilometers squared of facade is gone. So they have to be rebuilt. And of course, that means that market demand will be higher on the flat glass. But I don't know, in the current situation, current economic situation, they'll try to put probably single pane glasses. Just ignore the really all coatings, all efficiencies, and because immediate need is really to have some rooms isolated from outside. Initially, probably this, I believe that single pane glass or flat glass, not coated ones, will be needed more. For the coated glass, as the economy develops, I believe it will be there. But the war is affecting not just the really market in that way. All the logistic has changed, and all the production facility, communications, and production facilities capacity is under question, especially in Ukraine, Russia, and in that region.
Okay.
Good. Yeah, you was also talking a lot of this energy efficiency, which is obviously very important, and those coatings. I must say that if I remember in the 40 years what I have been in a business, it has been developed, let's say, very much to compare, let's say, 30 years ago when the first Lowy started coming in the market, and was it in Germany 95 when it's coming must to use it, the Lowy class, but also the solar control and that sort of things. And like you mentioned it, that the double glazing dominating the south and central European market, and the triple glazes mainly in the northern part of the European countries. How do you see that one? Is there the possibilities that we can start to use it, those smart and switchable glazing more, also to get it more energy efficient, basically in the southern part of Europe where solar radiation is higher compared to the northern part of the Europe?
Well, Yoma, when you think of cost of a standard cubic meter of a gas and the way it goes, you need to improve the energy efficiency everywhere you can. But currently, those really switchable glasses, switchable coatings, are still quite expensive. And actually, the progress in electrochromic is not as much as we like to see it, really. And the penetration is quite small. There are only a few places really apply this electrochromic windows. And I think of and look into those applications deeply, I can see there's always some kind of support from the governments or subsidized projects. When it comes to really pay for it individually without really thinking of, oh, it's not too expensive, it will be penetrating. But currently, I don't think electrochromic is going to go fast enough to see everywhere. But those Lowies and solar Lowies is penetrating quite nicely. And then despite this economic situation, I believe that increasing the energy prices will improve the penetration of Lowy and solar Lowy coated glasses for window applications. That's my opinion.
Sener, there's another question here. It's about bird-friendly glass market. How do you think this is going on?
Well, honestly, we've got Bernard Savet in here, who's the really guru of this kind of figures. When you look at the actual market and projection of the market, it's quite fluctuating. you can put the error bar as big as the actual market itself. It is quite difficult. I tried to really put those figures there. It is going up, but as you were just suggesting, we don't know what will happen after the war, and what will happen. That's just not Ukraine. The other part of the world, it's not really stabilized. When you have the stable world, the demand for the energy efficiency will become more and more important for the people's life, and it will grow, I believe, not just the glass, but the coated glass. As the architectural applications, as you can see, the use of glass is getting higher and higher in any new design of a building. You can see glass everywhere, outside and internally.
Good.
Even really some steps are glass in one of the shops, probably. I wouldn't give the name, but so glass is allowing itself to be used in any architectural applications, in any part of the construction industries.
Okay, thank you. I think this